So basically, I was telling about the mass temper system like yesterday, right? So yeah, as you can see here, this is the mass temper system. Okay, and in this one, you can see this is the mass M1. Okay,
Hmm.
M1 or M. You can consider it as M. And here this is the spring constant, and here is the damping constant. Okay, and suppose I want to apply some force into this system. Okay, and which is called F. Okay. Yeah, so uh, when I want to write the system equation which considers equilibrium into account. Okay, like force equilibrium. So
Yes.
when I want to have some equilibrium for the force, then how I can do it with the help of the free body diagram, right? FBD. This is the free body diagram. Okay. This is the free body diagram for mass M. Okay. Instead of consider here, instead of M1, you can consider it M. Okay, because I have written the system equation in the same format. So yeah, suppose in this case, when I'm applying the force, so this is the force which is being applied. So this, suppose force direction is in this direction. Okay, then my displacement will be in the same direction, right? Yeah, am I audible?
Yes. Yes.
Yeah.
Yes.
Okay, so suppose with the application of force, the body moved in x direction in the right hand side, then there will be a mass and acceleration being produced with the help of the mass system, right? This is the mass. So yeah, this will produce a mass into acceleration output. So that output will be equal to ma, which will be in opposite direction. So how can I say that it should be in opposite direction? According to Newton's law, applied force is equal to ma, right?
Yes.
So whichever direction the force will be, the opposite direction will be the mass into acceleration.
Yes.
Okay, so
Hmm.
that's why it is in the opposite direction. Okay, so this is being done. Now the already existing forces like the kx, okay, this will be this force, spring force, which will definitely suppose if I pull with the force in this direction, then these elements will try to pull it back, right? These two elements.
Yes.
So this means that the direction of force will be here. In this is for the damper, and this is for the spring. Okay. So this is all the forces that is acting on the body, right? So
Yes.
now coming to the system equation, when it comes to the balancing part, force, okay, the force which is this one,
Okay.
and then force is equal to, force will consume all the things with mass into acceleration already, which is producing the acceleration. Then the force that is being stored means the energy that is being stored, and it will be counteracting the force with the help of spring will be kx. Kx is the force from the spring. Next is the damping force. Damping will only happen with the respect to velocity. Okay, so this is the velocity, not with displacement. Okay, till this point it is clear.
Yes. Clear.
Okay, So now coming to how should I write the same equation in the form of a state equation or a system equation. So how I can write it? So acceleration I can write like a is equal to d by dx by dt square, right? And velocity I can write dx by dt. Okay, these two forms I can write these two elements. So when I am doing this one, so suppose I can write it like dx by dt, again
Yes.
d1
By
by
dt.
d, yeah, with the this one also with one more dt. Okay, so this one is the velocity, right, which
Yes.
is this one. Okay,
Mm.
so yeah, suppose I want to write the velocity in the form of dot. So how I can write velocity? I can write in the form of like v equal to when dx by dt is there. So dx by dt I'm representing with the help of x dot. Okay, and then I'm representing acceleration in the form of dB by dt. Again, this could be also written as dB by dt, right? This one, which is similar to this one. This is V, right?
Yes.
So dB by dt. Okay. So what is dB by, this is dB by dt, right?
Right. dV.
So yeah. So now V is equal to x dot, and then again I am differentiating again with respect to time. So there will be two dots.
Right.
Okay. So this means A is represented with the help of x double dot, and this one is represented with the help of single dot. Already
Right.
we have x. Okay. We have already x. We if we know x, then we can know v, and then we can know a. Okay. So yeah, till this point it is clear.
Clear.
Yeah. So the same thing I have written it here. I have replaced a with x double dot and kx, and then this one v with x dot.
Okay.
Okay. Now what I will do, like as you can see here, this is the most variable that is changing with time, right? Because it has
Yes.
two derivatives with time. This changes very rapidly and represents the most dynamic part of the system, right? So most dynamic. So if I can move this most dynamic part into one side, then the most dynamic part can be represented with the other dynamics, right?
Right.
So
Right.
for every system that you design, you need to write the system equation first, like this one is the system equation. Okay.
Okay.
Then from the system equation, what you need to find, like how you can represent everything in the form of one variable. This is all in the form of x, right?
Yes. Yes.
Yeah. So after that, what will happen, like the orders, which is the highest one, you need to keep it in the left hand side. Okay. And the remaining part, you need to organize and write it in the form of this. Okay. Again, this is not a simpler one because yeah, there is some calculation can be done further on. So what I did, I just simplified. As you can see here, this is x dot, x double dot. This is f by m. Okay. Then this is k by m, which is coming from here. And the third one is coming from here. Okay. Yeah. So it is done now. And
Yes.
as you can see here, this is representing the acceleration and this is representing the velocity. Okay.
Mm.
So this is how the system dynamic equation will look like, and then we can start the modeling based on this.
Okay.
Yeah, so today we will see this maybe take 2 classes. Okay.
Mm. Mm.
This will be a basic one, and then
Okay.
based on your existing knowledge, this is a suspension system. Okay, for car
Mm.
suspension system. This
Okay.
represents the vehicle body,
Okay.
and this represents the vehicle tire.
Okay.
Okay,
Mm.
so the tire will hit the ground, and based on that, one force U will be generated, and that
Mm.
will be solved here. Okay,
Okay.
so basically, yeah, once we complete this task, you can take this as an assignment.
Okay.
Yeah, and you can create the system equation based on the two mass system. Here we are saying only one mass, but
Mm.
yeah, but here you will be seeing two masses which are interlinked, and
Mm.
based on
Two
the
subsystems.
yeah. So as you can see, the acceleration is also involved in this one, which I have not included. I
Mm.
think because this is an up-down motion. Okay,
Mm.
it is not like
Yes.
this type of motion. So
Yes.
you can ignore the linear acceleration, and you can take g into account, and you can do the model creation. So we will see first this part, okay, in your
Okay.
PC. Yeah,
Okay.
and yeah, can you take a screenshot of the equation here, or the whole is better?
I think you should share subject. This is not
Yeah, you
full
can use the
screen.
snipping tool maybe to take the screenshot.
Okay. Mm.
Yeah, is it all clear, like how you can come from a actual system into your system equation?
Yes, yes, I understand.
So this will be same. The only complication comes when you are dealing with this part. If you are able to solve the equations properly, then you will have the system dynamic equation, and that equation you can use to model.